All right, well, welcome everyone to another lecture at the New York Institute of Technology. My name is Nader Vougoussian. I'm an associate professor of architectural history and theory at the New York Institute of Technology. Before we start, before I introduce this evening's presenter, I first want to say offer thanks to my colleagues on the lecture and events committee, particularly Pablo Lorenzo Arroyo, who's the chairman of the committee. I'd also wish to thank Dean Maria Perbolini for making this possible, as well as Susan Sternberg for administering this evening's events and our series in general. So this evening's lecture is Professor Hyun-Tae Jung, and it's an honor for me to introduce him. He is now in his second year teaching at the New York Institute of Technology. Prior to joining us, he was at the Louisiana State University in Baton Rouge, teaching primarily design and studio. And before that, he's taught at a variety of institutions, including the Parsons first and foremost. Then he was at the University of Nebraska. Then he spent a number of years teaching architecture and studio at Lehigh University. He's also taught at Columbia University. He received his PhD in the history and theory of architecture from Columbia University, which is my own alma mater, and it's actually the first place where I've had the privilege and opportunity of getting to know Hyun-Tae. And prior to that, he conducted his undergraduate study at Seoul National University, and then also obtained there an advanced degree in architectural theory, where he developed a special research interest in the Frankfurt School. Hyun-Tae is a renowned expert in 20th century American modernism, among other subjects. And he is currently completing a manuscript for Bloomsburg. It's Bloomsburg Press? Bloomsbury Press, excuse me. And the title of the book, can you remind me the tentative title of the book?
Architecture of Skidmore, Owings, Merrill.
The architecture of Skidmore, Owings, and Merrill is the focus of the book. And I think that this evening's presentation is going to intersect with the concerns of the book. So I'm just really thrilled to call Hyun-Tae a colleague. I'm able to work with him in our global architectural history course this semester, and I hope that our students too take advantage of his presence among us here at the Institute. So without further ado, I'd like to pass things on to my colleague Hyun-Tae. Afterwards, I hope that we can have a real spirited discussion and conversation about some of the broader issues raised by his presentation, which is interestingly enough going to focus on well, I'll let him introduce the topic. I think it's fascinating, to be sure. So I'll pass things on to you, Hyun-Tae.
Okay. First of all, thank you so much for having me today. I appreciate the committee and then Dean and Susan allowing me to have this opportunity. It was yesterday, there was a very important lecture at the School of Architecture. So I worried about the timing. So I sent the email to students, ask their help and telling them, if you come, I will make it short and fun. I don't know, I see a lot of students probably, they took the bait. So I need to make it relatively short, because yesterday, Mr. Bergman of BIG actually presented including introduction for 47 minutes and 30 minutes discussion. So I tried to make it that way, but I don't know whether I can do. All right, today I will talk about can you see the screen? All right. The topic is sugarcane and asbestos. It's more I've been always interested in like American architecture, particularly not like really generic conventional architecture tradition. I'm more into like, business side, technological side, and how those fields impact on, formal architecture tradition. First of all, it's my second year. I've been teaching history theory and then got a PhD and then working on a book like, about SOM from Depression to Cold War. And, while doing research on the book, and then I found a lot of like really interesting subject, but somehow like it's a little off. Like probably you will see, it's not really about modern material. It can be more like inclusive, more comprehensive. We'll deal like, I will discuss it like many different issues. So I hope like you don't really get into details too much, keeping a little distance, try to see big picture. Then you might be able to catch what I want to say.
Hyun-Tae, sorry to interrupt. You're showing 2 slides at the same time. If would you like to blow up the main one?
Is it 2 slides?
Yes.
No, that's 1 slide.
Yes, but you're showing the next slide also in the.
Oh, okay. Just that one. I don't know how to do it. Yeah, I
don't worry if not. I mean, sorry, I didn't mean to interrupt so much.
No, I think it's better. I saw the trouble last time with the Jonathan, so I don't want to have the same problem.
Yeah, that's why Jonathan was.
Let me do it again. So I will share the screen. Oh, this. Are you good? Do you see all side or one side?
We see both
Still the same.
Yeah.
No.
Don't worry if not. I mean, you can maximize the screen and then you show as it is showing now.
Let me try this way.
I think you can just do slideshow.
Yeah. Can you see now?
No, you have to share the
oh, okay.
PowerPoint.
Yeah. Are you good?
Yes.
All right. Okay. So this is can you see this?
Yep.
I'm starting with this movie. Like probably many of us who probably like old enough to watch this movie. It was a Planet of Apes, 1968, and then the movie is about astronauts traveling in the space, and then they were lost, so they were like in hibernation. They woke up, and then time passed about 2,000 years. So they landed on the wrong place. Not the Earth, but later it turned out to be Earth. They found their, chimpanzees controlling their like intelligent species. Humans are like kind of primitive. They were like animals. And then watching the movie, I was like, after watching the movie, I was haunted by the image of, monkey controlling whole world for a while. My childhood nightmare. The reason is like one side, it was like recently it came to my mind, like this is like why he was living there, but he didn't see a trace of human activities, like particularly garbage. That was kind of shocking to me. Like in the end of the movie, this is the final scene. He says, "I am back, I am home." All the time he was, we finally really did it. You maniacs, you blew it up. Damn you, God damn you all to hell. So he is crying almost, Then it was because probably something happened. Humans destroyed Mother Earth. So entirely like, just self-destructed and went back to like history, probably primitive. And then, somehow, apes became intelligent and then dominant species there. So this is a final scene. So like, what are we doing somehow? But like, the other case is like recently, like when you see the issue of garbage or human trace, these days movies all about like leaving traces. So if you see like this is part of The Walking Dead, and then you see like this image of empty, earth, it's an empty city. There is like only traces. There is no human, just one person riding horse. The whole continent is basically like empty. But on the other hand, here, that's more interesting. The Walking Dead people are gone, but like those dead people are like almost garbage human. So they're walking around their earth. So there are like unavoidably, there are like, traces. And then even like, probably many of like younger people know Game of Thrones. That's also like Game of Thrones is like night walkers. That's like human, but at the same time, non-human. This is kind of like going forward, but at the same time, not entirely disappearing. Trace, like for us, like what is happening right now in the earth, on the earth. So this is one example that's called the Great Pacific Garbage Patch. So they're like a massive garbage patch floating like, ocean. And then two of them probably like big ones in Pacific. Like you can see, this is like just flowing around. It's a size of like much bigger than like France, like 3 times bigger than France. And then it's traveling all the time. It was found in 1990s, and then it's getting bigger. And then you see like all the garbage, but also this particle. And then when plastic gets older and they fragmented, and then the plastic becomes part of like it's, you can't see them. So it goes like, fish catch them, and then you catch fish, fishermen catch fish, and it comes to us. So it's through like some kind of food chain. And then this is a situation here. This is what you see, like a massive, like, patch, the size of like 3 times bigger than France, and 1.8 trillion pieces of plastic. We're talking about only part of that. We're not talking about all garbage. And 20 pieces, like 50 pieces per every human being, 80,000 tons floating, of course, and 92 large objects, meaning it would get smaller and smaller. So it will melt almost. It's micro, like, particles soon. And then this is like on the side, this is like Singapore. I mean, Singapore people like, control really clean, but you can't stop like this garbage coming to the ocean, shore. And when you think about like this trace, and we can think about like, what if like probably something happens like, many thousand years later, whether people would see what it did to the earth. And then what about like agriculture? So I thought like, what about like sugarcane or sugar production? Sugar production is in general, not a big business in the United States, but some group of people like very, very influential, strong politically. So you can see like, some part corn, sugar cane, and then sugar, like sugar beet, and sugar cane is this red part. Particularly, the reason why I'm talking about sugar cane is somehow it intersected with the architecture, because sugar cane soon became building material, recyclable in 1920s. So like it's a revolutionary sustainable technology in 1920s. And then you can see here, 1940, like 42, about 42% of sugarcane come from New Orleans area, Louisiana, 48% like coming from, Palm Beach County, like near, like Florida, South Florida, near the Everglades National Park. And then we'll talk about like here, why? Sugar itself is like in the United States import a lot of sugar from different countries, like India, for example, or Brazil. And these like among importing countries, the United States import a lot of sugar, but also like it's strangely, sugar, the price of sugar in the United States is twice as, it's more expensive, much more expensive than international price. It's like almost double, because there is a special bill. So like the federal government to pay this sugar producer. So like it's a kind of like extra money. So like, for example, about 10 years ago, United Sugar got about like a $55 million kind of like extra funding. And then like the production itself is between like, mainly Florida, Louisiana, but Florida is much like, it was stronger, but still like more. And this is a scene of sugarcane field. It's now probably, it started like somewhere in the late 1920s. Before then, Florida wasn't known to be like, sugar land. It was more like, different crops, but the sugar really became prominent in like from 1920s, 1930s. With the help of strangely building technology or building boom of 1920s. This is the current location, Lake Okeechobee. This is main area along this lake. So this is more like sugar land, so this, sugar cane field. And then like below here, Everglades National Park. The problem is because of these like sugarcane, cultivating the swamp area here, water. And the problem is the water quality gets like, continues to get bad because sometimes like, farmers are pumping up to the other side and then the lake is contaminated, water coming down, going to the Everglades. So last couple of decades, it became really, really serious problem. So federal government tried to clean up, state government tried to clean up. So there was a program to buy the land from the producers. But mainly there is this companies called the Big Sugar. There are three main companies conquer whole area. Here, 95% of land is owned by three big companies, which hire lobbyists, and then other also donating money to the politicians as well. So like historical flow, you can see at the corner, the water comes and then goes down. Right now, it's a totally changed the flow, and then also water contaminated. And then every year, what they do is quite interesting. So like about 300,000 acres of Western Palm Beach County, it's a burning. If you burn the sugar cane, it's easier to like harvest. So 300,000 acres they're burning every year. And it causes a lot of like, problems to local people. So you can think about environmental justice, like, movement. And then, but at the same time, people complain because people have a really health issue. And then United Sugar maintains the burning is still the best way to dispose of the leafy portions of sugar cane that aren't needed to produce sugar. So they don't really care. They just keep doing. They use pesticide, they use like a fertilizer, so contaminating. So like the federal government, that's why federal government try to buy their land, but it's billions of dollars. And you can see there is a school in the middle surrounded by sugar cane, and you can see the smoke here. And then the respiratory disease is so prevalent here. That's like one of the most dangerous places to live in the United States. Air quality is so bad. But there is not much like at this moment people can do. The main argument of critiques, well, like a farm workers advocate says there was like really abuse of labor. So it was like there is long history of slavery there. Even like 1940s, the 50s, there was a federal lawsuit about like this against these companies, and then they actually settled outside of court. And environmentalists they worry about like the quality of Everglades ecosystem. It's getting worse and worse. And consumers worry about like just like pumping up all the sugar. They are not producing actually. They don't have enough, so they import and importing, and then they get paid extra by federal government. So all these issues continue somehow. But my point here is actually, it's not about like just a sugar sugar cane fields itself. It's like the Florida sugar industry itself. It's not really traditional farming. It's actually came from 1920s and 30s. So 1930s and 20s, it's directly connected to building industry, and then building material manufacturer and some architecture firms. So that's why somehow like this is somehow it's part of us, part of our issues. So 1921, there is a company called the Celotex. You can see Celotex, this company, revolutionary, praised by everybody. So from bagasse to building materials. So like you have just leftover material from sugarcane, then squeezed and then extracted, and all the sugar sweetness, and then left over, that's bagasse. And then they make like biomass and then compress it and then turn it into insulation material. So there was not much concept of like insulation in like 19th century, but like this was the beginning of industrialization of insulation. So there was a key figure called the Bro Darborg, businessman, financial manager. This is the person. And then there was another person, Carl Munch, mechanical engineer. Later, these two people become president and vice president of the company. So they actually set up like Celotex company initially in Chicago, and then planted in like New Orleans, Louisiana, Jefferson County, Jefferson Parish, right next to New Orleans, but it's a small area. 25, because they had, their success was so amazing. They actually like, production was so going well. They couldn't find enough bagasse. Initially, the reason why they set up the factory in New Orleans was that's a kind of like territory of sugarcane production. And they wanted to get like bagasse continuously, but there was some kind of famine or other issues. They couldn't find enough bagasse. So they imported some of them from Cuba. Didn't work. So they actually decided, okay, what if we build our own sugarcane field? So they started like, sugar company. So that's actually Southern Sugar Company. So suddenly this building material company owned the massive land of sugarcane and sugar company at the same time. But right after, like a couple of years later, they had a depression. So it went through like, bankruptcy and receivership. And then it turned into like after reorganization, it became Celotex Corporation. That's not the end. Celotex Corporation became really, really like successful after that. In 1931, US Sugar Corporation by Charles Stuart Mott, who was the vice president of General Motors in Detroit, and he took it over and created Empire. So before then, there was no like really organized like large scale sugar cane, farming, but suddenly because of this Bro Darbo, businessman, owner of president of building material company, the sugar dynasty actually built in Florida. So in 26, like study 21, 25, they set up like a new company. This town of Clewiston, Florida, this person is the founder of that town. Still like, United Sugar Corporation is headquartered there. Celotex owned approximately 35,000 acres of land for sugarcane cultivation in South Florida, integrating sugar production and building material manufacturing. So suddenly, sugarcane cultivation and building material manufacturing just, under one umbrella. This is like you can see sugar cane there, and then extracting all sweetness, and then putting here, and then processing, and then putting some chemical and glue. And this Carl Munch, he was also like a mechanical engineer. He invented a lot of machines. Also, he had a lot of like patents. So this is some of his patents: press, and then with the heat, and then with the glue, and then making flat. That's kind of like insulation board. And then later he developed like all different projects. He has somehow like a tile, like concrete panel, all these things. He had an amazing list of patents. So this is a Celotex. It's cellulose. And then they named it Celotex. This bagasse compressed, that's a board, that's a Celotex. So initially, Celotex was hailed as a revolutionary, material. So many like chemical engineering journal or like, Scientific American called it saving at least 1/3 of fuel ordinary use. So like energy saving was amazing. Celotex assured the stands before the war, therefore as a most remarkable production. So like a lot of people saw it as like groundbreaking, and they didn't use a sustainable development, but like somehow close to that. And then this is the factory they had, and they built in New Orleans. So sales, like you can see from it was built, started in 1921. So 1923, 32 million feet of this board. And then like just the following year, it's more than doubled quickly. And then they need bagasse. That's why I said like they studied Florida. When they studied like building material, you know, they actually studied like have a catalog. So initially this catalog, so you can see very naturalistic, and then like a vocations course, so vocational home. It is interesting, you can see here, somehow like 1930s industrial designers kind of streamlining, and somehow a little bit like similar to reminds probably some of you like Frank Lloyd Wright. And this is like very simple, like bungalow. And then you can build these things with very easy, their materials. And then 1940, they actually like had a, you know, they produced a lot of catalogs. So this is the company, well, like, you know, their material, their catalog 1940, it's all about products. They say, you know, all these things was basically Celotex. So Celotex is this bagasse compressed, right? So insulation sheathing and insulation lath, insulation plaster, finish. So everything through goes those things. And then the whole catalog is basically like about product itself, their products, how it is used. So like it's a big advertisement. Like it's a book, but the, you know, catalogs, real catalogs. They don't really talk about architecture at all. They don't talk about like housing, anything. It's like, you know, the interior, they look at the taste, like, you know, very, very, you know, conventional, putting like very colorful as well. Then about 1938, 37, they invented new product. They got a company in Canada, which owned the mining company, asbestos mining. You know, asbestos was like 1920s, 30s. It was a like wonder material. It actually like, you know, like incredible material. It was like amazing insulation, or like it had a lot of use. They didn't know about all the bad things at that time. They knew a little bit 1930s, there was some cases, but it wasn't really widespread. So Celotex started to combine things together. So with the cement and asbestos. So they developed this product called the Cemesto. So Cemesto is basically, you know, combination of asbestos and then cement. But when it breaks, it actually particle comes out, then it becomes a problem, right? Not a problem, it's a serious problem. So you can see here, they developed this interesting like wood column here, kind of panel system, cotton wool system they call. So like here, the wall goes, and then very fast construction compared to like previous one, like conventional construction method. So like you can see the inside is still like bagasse, like it's Celotex, exterior is Cemesto. So the product is called the Cemesto, but it's you know, cement and asbestos on the two sides, in the middle insulation. 1943, they like, you know, got confident, but they also like present, they have like an interesting experience. They actually was, they met like strange groups of people, different groups, not so like, you know, familiar to them. So Celotex Corporation got met this John B. Pierce Foundation, which was like, which is specialized in housing research, medical research, and then ergonomic research. And then very, very prevalent in like, famous in 1930s in terms of prefabrication research. And then also the medical research group is still very strong at the part of Yale University. Rob Davidson was a person who became really like the, you know, like, you know, really expert in curtain wall design, curtain wall technology. And Glenn Martin Company, they work for Glenn Martin Company, which is part of like Lockheed Martin aircraft company now. John Perel was the engineer and contractor, and then architecture firm Skidmore, Wings, Mill. So these all group got together. So like 1943 was a turning point for them. And Pierce Foundation had like from 1932, they had all this housing development. This was a plywood, the rest of them all Celotex, a Cemesto board. So they're pretty close. They actually used it to get together. So Pierce Foundation, Rob Davidson, the director, and SOM consulting architect. So SOM basically designed this thing. So I actually published articles about these issues somewhere else, but we need to, I think like, because we're talking about materials, so it might be a good idea to, I thought it might be a good idea to, talk about a little bit. Glen Martin housing project is outside Baltimore. The main factory was, during the Second World War, done by Albert Kahn. And then another one was Omaha. So they had the twin factories, one in Baltimore, the other one was Omaha, Nebraska. And then they needed a housing project because they needed extra housing because it was a little bit away. There was like not enough housing in the city. And then SOM Pierce Foundation were brought in because Pierce Foundation had the patents for prefabricated house. And then SOM was their consultant, and then SOM did most of the architectural work for them. And Celotex company was the main material provider. So they actually started working together there. So 300 houses, this project, and the six, like the other one right next to the project, there was another one. So they built the 600 identical houses. But you can see the difference later. Later you will see variations inside. Then you can see a relaxing evening in the living room is enjoyed by Mr. or Mrs. William Hutchison. I don't know, looks like me and my wife these days. I love her. And then like with this, what was happening when they built this one, they actually like developed like this prefabricated technology. So using this called horizontal building technology, they actually found a way of like, installing the site and building very quickly. The team, each team, they use like kind of like a reverse conveyor belt system. So like a Henry Ford car, they were highly inspired. So materials are all coming. Each group does, same thing. Foundation team does foundation, like a skeleton team does skeleton, and all different teams are just moving forward very quickly. So they could build 35, like one house, 35 hours. So that means if you have 7 people, you can get it done in 5 hours, moving really, really fast. And then they actually, they called it the horizontal wall system, curtain wall system. And this is a like really famous image, like you can just see, it doesn't start like from 8 o'clock, always start like 7:59 because they use the same thing. Funny, probably to give a sense of precision, but you can't really buy that, but So 7:59 to 4:15, so almost done. And then entire work. And at the same time, actually like Celotex Corporation, Pierce Foundation, SOM worked on like another project in Arlington Farms. It's right next to Pentagon. You can see here Pentagon. Pentagon was built in 1943, and this housing project was also done. So there was a female workers for military and Pentagon. They called like it's a girl town. So there was like big, they housed about 7,500 female workers, federal workers. And here, again, they use exactly the same material. The point here is like, it's not the material company provide materials and architect use the materials. There was kind of mutual learning process. So the material company understood the importance of design, and then they actually like developed, they invited like the architect of SOM to be like, to help them. And then architects also like based on the material, they developed more like, the construction technology based on module. Here, this is a part of like a study by Kier Moy. I think like it's quite important in this context because in general, the history of building materials in the 20th century is a narrative in which materials increasingly became proprietary products. So from materials to products. So like it's shifted, like, like now so-called materials, like it became product. And then it's like, endowed with all kinds of different things like, unique research, like, ergonomic research, and then, technological aspect of buildings, and standardization technology, other protocols. Like, it's not just like designing, like building things, it actually incorporates a lot of different things at the same time. Also, the role of architect, as you see here, changed. Buildings of 20th century became assemblies of products, and accordingly, architects increasingly became a hybrid of building design professionals and professional consumers of a product. So like, you choose products, and that became really important part of your design. So when you design curtain wall, you check like, specifications and your size, and then like, that's what you do these days. And then in SOM, like in 1942, when they published this article, the New House of 1940X, you can see the parts similar to the logic of the Celotex Corporation. And then they wanted to do something like this. This is like, the Ford company manufacturing conveyor belt. They want to do something like this, and then, delivering to the site and building right there. And Pierce Foundation also developed like this even electric wire system, because when you have a new wall, you need to worry about wiring and outlets, all these things. And then Pierce Foundation also like did the research about medical research in the domestic environment. It is interesting here though, they did like really, you deal with the lung here. And then they built, based on this data, they built semester homes. And then later, semester homes, like known to cause, cancers, like particular lung cancers. So that's like kind of like irony here, because they did like study of lung in a domestic environment. Anyway, the other one is family behavior. So they wanted to figure out when you have troubles inside the house, their concept of design is conflicts in a space and time. So like getting rid of that, like a traffic. Let's say when you wake up, a whole family wakes up at 7 o'clock, everybody wants to use restroom at the same time. That's like conflict. So like architect job is, getting rid of those troubles. And then measuring happened. So using DAO, now like we do these things still. And then there are other like, architecture standard books or graphic standard, all these things. But like they did the photographic method. So try to understand humans, but like doll from 3 different angles. You can see tiny doll at the corner. And they build models based on your movements. So when you move around, connecting, this is a man dressing, and then it's a 2-dimensional. So when you wash hair, it's not about minimum space. They thought it gotta be like, sufficient space. They wanted to understand how much space you occupy. It's when you move around, right? So this, like in this case, this here, it's not about chair and you sitting on the chair. When you move your body, how much space you occupy, and then they wanted to represent in volume. Space shapes. So this is like this one on top, right? This. So when you move to change the cloth, like all the point connected and creating volume. So like human activities or human behaviors actually, could be quantified. But like it's a different human. It's not like human you can feel, sense, or these things. This human is very, like a human which can be divided into like, data. And then this 1944 by John and Tenza. And then Charles Eames got involved. So like there was a special issue called the prefabrication. And then this is the same thing, like in principle, like this is more like using film. So what is a house? When you occupy space, so it's using exposed film. So you as an architect, not just a prefabricated house architect, but if you're an architect, you've got to understand student of human behavior. You've got to be scientist. You need to like understand the importance of humidity, dust, or like, or psychological aspect. And then you got to be like economist, money matters, and industrial engineers. Probably this part was like really, came from Celotex. So this is a human now. And then the operation can be a house. So from parts, you can combine something like, you can get from market, and then you create. some final product like this. A variation can be like industrial product, like car changing like a shape a little bit. So like it's probably 6,528 variations. So it's not like really uniform. It can be many different things. And then like as you see here, this is Celotex Corporations. They actually developed this kind of variations as well, based on like slight changes. So like a slight contrast, strong contrast, similar color, different colors. So all variations. You can have like all exterior variations, interior variations, and then doors. And then the same team, which started like in Baltimore for Glen Martin and then and Arlington Farms, and then got involved with atomic bomb development called Oak Ridge, Tennessee, from 1943, same year. Everything happened very quickly. And that time, SOM wasn't like a really tiny firm. Celotex was like, strong material company, but at the same time, they didn't really fully develop their kind of like direction yet. They produced like products, larger products, but soon you will see in their catalogs, they actually found a different direction. And then this is Oak Ridge is probably the best job of emergency housing to come out of the war. You can see this is nuclear facility, civilian market, shopping mall. And then this is Hiroshima, the bomb site. And then like female workers, majority of them actually like brought from when they finished the high school all together. So they lived there. So there was no one, a couple of farmers, like massive like a reservation area. And then like, from 1943 to 1944, 45, it became a city of 85,000 people, civilians combined the military. And then that city was built by engineers, and Skidmore Inksmail built the city using Celotex material, semester board. So like a civilian part was separate. It was like creating city for like, for like probably 75 people, 75,000 or 80,000, 85,000 people to live comfortably. So everything was done very, very quickly. So semester housing, you can see mass construction here. They created variations quickly. And then they created like later, different like dormitories and hospitals. Here, it's a hospital, but it's not like you really cast in concrete or brick, anything like that. Everything was based on Celotex products. So product quickly delivered, stacking up. And then you can see it's called that market shopping mall. And then there's a high school here, there's a mall, and then there's other school. And by the end of the war, total housing reached nearly 10,000 family units, all like Celotex, and 13,000 dormitory units, and more than 5,000 trailers, 16,000 hutments or barracks. But the first two items were done by SOM with Celotex materials, but the other ones were like brought from TWA. And this is a tricky, like in 1943, I showed you the catalog of the Celotex company. 2 years, like in 1943, like in the middle of the collaboration, so like SOM, Pierce Foundation, and Celotex Corporation. And they learned things here. Their direction was not about like, detail oriented. So now they want to talk about future. So your miracle home of tomorrow. And then talk about like now much more advanced. It wasn't like really catalogs anymore. So it's more scientific. It's about weather, sound condition, light condition, and then miracle bathroom, and then kitchen tomorrow. All different drawings. Like now, like try to be more like, reasonable, convincing. And then they invited 3 firms. First one was Nathaniel Owings of SOM. So you can tell their relationship because SOM 1943 wasn't important at all. Very like rarely known. So it's a tiny firm because when they sent their people, they will have like 12 people in New York, 12 people in Manhattan. It's a tiny firm, and then it wasn't really like, known atelier. The next one was George Frederick Keck, like renowned futuristic architect, like he designed the House of Tomorrow. So he was a big shot there. And the third one is Antonin Raymond, this Austrian-Hungarian architect, like really known, like he worked with Irving Gill and then Frank Lloyd Wright. He went to Japan. He was like, really, really important figure. But suddenly you can see SOM was #1 and talked about future. And, all these groups, it like went to a different direction at the end of the war. So the war ended in 1945. So like SOM went to one direction. They went to like, they decided to design because they got commissions in the Oak Ridge, Tennessee. So all the pitched roof, like conventional buildings are gone. So same people designed a very, very modern building. And then they focused on design. And then they didn't take any individual housing commission at all. After that, they decided not to take any single family homes anymore. So it's like rule. Not housing, but like, single family homes. And then, like became the designer of like one of the most famous post-war American architecture firms, right? Union Carbide and Seagram, not Seagram, I mean like, Lieber Brothers, and then like, any other buildings in the city. So you can, I published this one in the, journal like last year about the module, how like single module worked here. And then like in the case of Celotex Corporation, this company, and became, really confident. Initially went in their like 1943 catalog, they actually, this is important. They said the working plans and specifications for all houses shown in this book are available through your Celotex building producers dealer, products dealer. So previously it wasn't really available. Now they say, yes, you look at the, like this wonderful design and then you can use the same like plan and elevations, everything. And then it made it available. They should just basically like publish many different designs. And they invited architects from all over the country. So basically they invited people from all over the country, basically different climate in the country, and then asked them to design and included in the book. So like they here, in this case, 20 homes. So like different locations, some Georgia, like in New Jersey, New York, and like Kentucky, in LA, Los Angeles, so all different things. And then they put like the concept in the end, and like products, like in the end. But product is not explaining anymore. Product is more like showing. And if you want to do that, just contact our dealer. So, it's became really, really successful company. One of like the most important like building materials company until like 1980s. So it was a very, very successful. It was one of major like building materials manufacturers in the country. So 1955, you can see they're continuing another 22. So every year they have like 20, 22, 25. Here again, plans, specifications, like all of these houses available. So if you order, we deliver material, you can build it. And then there are some variations. So like you can basically, they have total confidence. All the materials are available. If you choose one, we'll deliver. So your architect will just make it happen. And then like, there's not much, like design is very, very advanced, like very abstract too. And then they don't really tell how to. Initially, they explain things, how to put nail, like very technical information. Here, they don't really do anymore. So there is not much, like you can read, but at the same time, there is not much you can do. In the end, there is this certificate, like say, lifetime guarantee. So if something happens, contact our dealer. So this is, I wanted to get it done by within like 47 minutes, but it's already 47, so I feel sorry. I will go like probably, 2 or 3 more minutes and then wrap it up. And then we think about like, like mid-20th century American architecture. We talked a lot like, like big skyscrapers, and like Americanization, like very technologically oriented. And then we know this is technological, also like a kind of technological understanding and scientific understanding of human body and human behavior. So like, in this case, architectural review, very famous one, Machine Made America. So we like machine somehow to like some Brit, but it's not the end. Actually, like if you look back, like from 1920s, 30s, we changed a lot more. So here you can see like this burning, sugarcane field. It's not like what we did, like as a profession, as a discipline. It happened, but we were not like entirely separated either. We're somehow there, we crossed the line. And then Celotex was like, they actually developed their ideas, some of their ideas from like, architects, like SON, Pierce Foundation. And architects learned some lessons from them too. So it's kind of interbreeding. So learned like business world, like, agriculture, science, and architecture, like of course, like a prefabrication, division of labor, ways, different ways, like, separation. And then, this, even they allowed like this church is like totally Celotex. This is a Celotex, prefabricated. This is a Celotex. So they brought the material, just assembled there quickly. And then these guys, labor house, it's kind of like brothers and sisters. And then coming from here, there. And these are not that far from here because these are like kind of like provided, but even though these houses came from different design, but the materials came from there. And based on this human understanding. So are we done? No, the threat to Everglades, going back to the initial, like the threat to Everglades continue. The sugar field, the sugarcane field, right? First of all, asbestos, like this is like continuous because there's a huge algae development, is red tide, right? Because of sugarcane field, like farming, cultivation, because of like excessive use of fertilizer, DDT, and like, pesticide, all like, they pump into the lake and then lake water goes down. So also like almost like this, like big sugar monopolized lake. So like it's becoming right now, there is a like crisis of like danger of flooding. And then natural ecosystem is a very, very like, threatened right now. And then there's a big sugar is so politically connected. They actually like they hired like 60 lobbyists last year, the year before, spending like $20-30 million, like crazy. So like they can't cut, even the government can't cut like this, extra money for this industry. So that is still like people try to fight against it, and then people like, try to somehow like, get rid of these people and then saving the ecosystem there. What about asbestos, cement? So Celotex Corporation manufactured asbestos product until 1980s. Some of their most popular materials, including asbestos containing insulation, cement, siding, roofing, and then even ceiling. The company also specializes in asbestos pipe coverings and paper sealing materials. Celotex now, along with its Canadian asbestos mining company, faced about 380,000 asbestos-related like lawsuit claims now, which equal over about $200 billion. Like it's by 1980, 98. So their troubles continues. And then we are right in the middle there. Like not like us, but somehow architecture is somehow connected that part as well. Or like we can think as a citizen of the world, we can think about like, okay, like, I am back, I am home. All the time it was, we finally really did it. Did what? Probably like 100 years later, we can ask ourselves, like, we finally did it. Like in this context, it's like we finally did it, like we destroyed Mother Earth. We destroyed ourselves, not Earth, but we destroyed ourselves as a species. But before reaching that point, I think we all like got to take responsibility. We need to figure out what to do. I hear people sometimes, we are as if we are innocent, we are problem solver, but actually in many cases, we are the problem too. Thank you.
Thank you. Thanks so much, Hyun-Tae, for that fascinating presentation. Before we kind of open things up for general conversation, I thought I would start things off with a question of my own. And I was wondering if we could interpret your fascinating historical analysis in part as a critique of certain prevalent preconceptions that people have about sustainability and sustainable materials. What I think you've shown is that this waste byproduct, it's called bagasse. Is it B-A-G-A?
Yeah.
Bagasse.
Yeah,
That
bagasse.
you know, it was, this is a waste byproduct that derives from the processing of sugarcane, that the intent originally was to essentially to recycle, to make productive use of this byproduct material, bagasse, through, for example, the manufacturing of these new insulation products that you describe, and later the creation of asbestos products, which serve to insulate people's homes. And in some respects, this usage of or this adaptive reuse or recycling of what was essentially a waste product proved successful in ways that were actually destructive in the long term, particularly in terms of how it contributed to, for example, the environmental degradation of the South Florida region. Is that sort of an accurate characterization of?
Yeah, I think so. Yeah, their intention was really not intention, like they wanted to make money, so that's not. And then they found a way of turning waste into, building material.
I see.
And then it was a keep going one direction.
Right.
And then they didn't really think about the sugar field that much. They just wanted to have a bagasse. And then people thought that they would produce sugar, but the sugar wasn't their intention. Sugar was, in their case, sugar was a byproduct. Their intention was getting the sugar cane itself.
So what are some of the lessons that we can take away from your study in terms of what it can teach us about recycling, about downcycling? In what ways can your research help further the discussions about sustainable materials and issues of sustainability as they pertain to the built environment? Have you had a chance to give some thought to that?
No, I have some ideas, but I'm also very curious about how other people would think of that issue too. So in my case, I have this little bit of suspicion about new technology always. I think it's my tendency, it's as if computer solve problem with TV, that kind of thing. So more moving forward.
Right.
So that actually scares me. So.
Right.
But when we focus on one thing, we don't really look around, but our job sometimes it slows down. Slow down, we look around, look carefully. And then that's one thing. So they didn't really know what's going to happen. They didn't really think about the massive, the disaster catastrophe, right? They thought that they were doing great thing.
Right.
They were not really intellectual people, they just, business people.
Right.
So, well, is it always understandable? That's a different issue, right? Are we all innocent? So no one really intentionally killed anyone. So everything's fine. Then what's going to happen to the earth? That's
right. Right.
So in my case, it's just at least one thing, ask yourself when you do certain things. When I attend architecture lecture, sometimes even not I enjoyed, I love BIZ, but at the same time, there's really strong optimism that actually makes me really concerned too. like, if you think of like optimism everywhere, but at the same time, you know, it doesn't really sometimes solve a problem.
Mhm. But rather can also create further problems. Yeah, I think that there's similar. I mean, I think I'm no expert in this subject, but as I understand it, the growing popularity of biofuels like ethanol has also contributed to growing scarcity in certain segments of the agricultural industry, and has actually contributed to food shortages that exist. That's another one of those unanticipated consequences of what was originally a an environmentally or a strategy to derive a more environmentally friendly approach to an energy problem. I'd like to open things up. Questions from our audience out there, reactions, thoughts?
It's a felt like a conversation. I just want to intentionally make it like more polemical to open up, you know, conversations. You don't have to ask me, but like you can.
Thank you really so much. I have maybe a couple of comments and a question maybe to end. You know, thank you for really a fantastic lecture, which kind of shows how history can become detective work, or that a way of working as a historian is about getting deeper into the relationships between architecture, industry, health, you know, our planet, ecology, and really sort of, you know, your presentation in retrospect for what starts with a truly optimistic, you know, I really believe that the company that you're about to narrate was all about recycling and upcycling and reuse of biomass material, and it would all be okay if it was fine for our health and fine for the planet, or the immediate environment as well, of course, and immediate nearby residents. What if, as a question, what if Celotex had never added asbestos to their material? Would they, in one hand, been able to have as many different kinds of products, from cladding to concrete structures and all sorts of additives, or would, if they would have just solved the problems to our health and the environment, were they on track? And is there a sort of strand of material research today that we can look to say that they can pick up the trajectory of working with biomass and also prefab and producing building materials that are readily kind of distributed and packaged as sort of total packages? Would they have been able to be either as diverse in products, or would this sort of nature of company, what companies exist today doing that sort of work with biomass responsibly in terms of the environment and our health?
I think like it's a sugarcane as insulation material is over, doesn't exist anymore because there are better materials, moved on. So they use like, you know, sugarcane biomass as kind of fuel, burning. So mainly burning, you know, refinery, the majority of them. Sometimes they feed the animals. That's like, you know, so I don't know. And then also like probably it's like would have been outdated already because there was a new invention of materials, synthetic materials. And then on the other hand, I think from the very beginning, it's kind of funny like that this building materials company was a predator in 1920s. They bought massive land. They actually got into like sugar, like cultivation business. They were farmers, right? They actually combined. They made agribusiness there, but they bankrupted because of depression. So right now they're like a mega three company, that's called Big Sugar in Florida. Actually, like, you know, occupies probably, it controls 90% of land, sugarcane field in Florida. They came from because of this predator building materials company got in, combined all the land, made a big piece. That was the beginning. So like from the very beginning, I don't know whether like being a predator there, and then whether the tail wagged the dog. And then they came back, they tried to do a better job, but like, but good thing was the company founder actually retired quickly. So he said he didn't see anything like asbestos problem.
It really shows the potential devolution of what we assume to be advancements. But I think you also pointed out that there were some advancements that were made in terms of limited customization or variation and differentiation, albeit in probably really disposable housing, likely. But actually some principles that, if brought forward, have great value. It's just it's an absolute pity that they made that sort of mistake without knowing it was a mistake to go through to add asbestos to their products.
Well, I'm no expert in asbestos products, but I think there are some people that still swear by it. And asbestos is actually still legal in the United States, as I understand it. There are many products that still have asbestos. Maybe someone else can speak to that more intelligently than I. I've had contractors tell me that asbestos gets a bad rap. Anyway, thank you for that question. Other questions and reactions?
I mean, maybe just as a comment, following up on what Tom is commenting. I think what's very interesting, Hyun-Tae, about your presentation and the function, if you want, of the actual critical function of having somebody like you doing research so specific to the relation between technology and architecture, especially in our school, right? New York Institute of Technology, School of Architecture and Design. I find it very interesting because there's many of us that we are looking into designing technologies, designing materials in terms of expanding the possibilities of architecture. And the research that you're showing us makes us wonder. I think that is, myself coming from perhaps more of a cultural background than a technological background, but trying to integrate the relation between technology and culture. You brought up an issue of the problem of technology relative to also to science, right? Like the focus of research and the inability in general, right, to look at the relationship between how these systems connect with each other, right, comprehensively, holistically, and to look at the full cycle. And that's actually the current, if you want, the current revolution that is happening in renewable energies. That renewable energies are not looking so much only in terms of what type of technology is going to increase in terms of energy, but also at the full cycle of how that energy is being consumed, right? That's why there are terminals in the houses measuring how that renewable energy is being spent or not. And that there's a full feedback in terms of, for instance, the embedded energy that the technology, how that technology is being produced, right? So that is go back and forth between origination and destination, looking at the full spectrum. So in that sense, I find it very interesting what you're bringing to us as a kind of a criticism, I would argue, also on looking at very narrow issues and not perhaps comprehensively looking at the full cycle. For instance, Nader was mentioning the biofuel. And by the way, all the way from the beginning in Latin America, at least because in Latin America, the production of biofuel was one of the first, actually it's a very old technology. Very quickly, especially politicians, they realized, look, you're giving cars food that is needed for people, right? So that was the first type of boundary. So there was a kind of an energy call or a kind of crisis call in terms of understanding that perhaps you also need to ask questions that perhaps are not so much to do with the technology, but also comprehensively as a society, and taking also critical distance. What are you going to do with that? But the problem is that if you do too much of that, then there is no research, right? So there is I think that we're in a moment of crisis in terms of how we look at the full cycle, how we take critical distance, how we integrate different disciplines, looking at the same problem from different point of view, and at the same time, understanding that our actions have a feedback and a reaction. And unless you enter into the evolutionary theory or an evolutionary active component of how the world works, you're going to always intervene in something without looking at the consequences. So I think that you're problematizing a full amount of issues related to science, technology, and humans. So I find that very interesting.
I think like when I do architecture history research, it's more about like, as you mentioned, the interactions between science, technology, architecture, all these things combined. They are not like you can't separate one piece. In many cases, they are working together. But like if you can't combine too much, that's like you can't like really do research because everything is connected to the other things. So like the network goes too far. So you need to set the boundary. So I agree with you. But at the same time, when you talk about like it is, when people talk about like, changing things, like, but at the same time, I don't know what is really changing. That's a historian. We look back, we try to find more as a like, Tom mentioned, it's more like detective work. We have a suspicion, we look back, we check things and like, what happened? What was really happening, that kind of thing. But like now, I love like BIG. I went to that office, I had a tour, but at the same time, I'm not talking about BIG, but in general, sometimes when people are crazy about new things, right? I don't know what it is. I can't be too excited. I can't be too pessimistic, right? But like, I can't figure out what it is, right? In that case, I look at people. Why that people? What make these people crazy about these things, right? What might be problem of these things? I can't figure out the problem itself, but I can figure out these people. So like then I take position. What if that's like really problem? What if it doesn't work out? So based on historical lesson, I just like, try to be more careful. We might try to solve technological problem with a new technology. What if we just slow down a little bit? We slow down a little bit. We think about whole things, like almost like meditation. We need to learn how to think slow, that kind of thing.
I mean, I think that's very well said. Thank you, Hyun-Tae, for this very nice historic research that you presented to us. But as you know, that if you go to the website of U.S. Green Building Council or BREEAM or several others that exist around the world, a lot of this material research now is online, and you can really see all the way where it comes from, when did they discover it being harmful, for what. So I mean, I think our industry is working on this, and there is a lot of good resources now. I haven't heard about the sugarcane. That's why it was so fascinating what you provided. But if you go into their websites, they would suggest blue jean, leftover blue jean, right, for insulation. Even though we do know that blue jeans also have a real serious problem with the dye process, right? In India, there's a lot of water sources being contaminated with the dyeing process. But anyway, I think it does exist, and I think that it can probably get better, but we have a lot more sources now than we did before about this kind of information. I mean, I think what's interesting about your talk is that you have also connected the industry, the expansion of capitalist idea of how things have to be produced so quickly to make profit. And then once that comes into picture, things happen so quickly, as you say, and then we lose control of it. I mean, I'm curious, for example, you showed some lung pictures and said that that they were proven, the material was proven to be harmful. But when was it discovered that it was harmful versus when people stopped using this material? There is several decades, right?
Yeah, lawsuit in like late 1980s. Like lawyers stopped the people using it. But like there was already people knew about the danger of asbestos from Greek period. Greeks, like ancient Greeks, knew about the strength of the material and the weak, the danger of the material. But 1930s already there are like some cases, but people kept using it because they thought it wouldn't be that dangerous. I don't think, I'm not like really against the old technology, but I think like, technology is some parts really good. A couple of years ago, there was this Danish designer created like this water bottle, water tank, like a circular. I thought that's amazing. It's a pushing, rolling. So these poor girls like carry the water like from far away water source. But he made this big plastic drum. I thought that's incredible. So like certain technologies, just incredible. It improves human lives.
I want to make a quick comment, then I want to go to a question that I just see in the chat area, and it relates to what Pablo said earlier. Just as a suggestion, Hyun-Tae, I was thinking it might be interesting to in order to look at the broader cycle, to look at the connection between the production and the demand for bagasse and the history of obesity in the United States. Because from what you're saying, this waste byproduct, bagasse, was actually driving sugar production. And I would imagine under those circumstances, the price of sugar itself fell rather considerably during this same span in time. And if that's the case, I imagine that the national diet was in turn impacted by this state of affairs. So it might actually be interesting to look at how this, how the use of this this waste product material in the construction industry actually relates to the history of dietary habits in the United States and the national diet, which raises other kinds of questions. So it's just something to think about. A question from Pedro Almeida. I hope I'm pronouncing your name correctly. How do those technologies influence formal and programmatic innovations in buildings?
It was directly connected. They're building the cuts, so like later design firms like requested certain size. So, based on specifications of a Pierce Foundation patent, they cut pieces directly delivered. So interaction was like instant. And then the engineers of Celotex Corporation was on the site. So they worked together.
Very interesting.
I have a question.
Please, Michael.
Yes. Hyun-Tae, thank you for this presentation. You have a nice casual way of presenting very complicated issues. And one of them that I thought is interesting from tonight is the kind of corporate role or control of decision-making in American architecture. The products, the idea of products controlling quality of life, the advertisement of products. And I think that's an interesting part of what you presented tonight. I think about the time, the beginning of your study, Sweet's catalog became a very important element in architectural practices, where the catalogs, sometimes I think growing to maybe 20 volumes, were all advertisements of American products. And in the 60s, there was a really strong interest in, and there still continues to be a kind of idea about off-the-shelf construction, not just prefabrication, but even the notion of connection of products to design ideas. But the more insidious one to me is the role that corporations have played in making products and determining what is our definition of quality of life.
That's like really, like, I totally agree with you. It's just so incredible. Even not just corporations, some like research foundations, they actually thought that they could like, quantify all the like elements of like quality of life. So like they could make sure your quality of life is good based on products they produce. And then that's like really, they don't talk about anything else. It's like really the shell, I described it like their human is empty shell. You don't really feel them much. You feel moisture. You feel like, dryness, air, temperature, but it's a different kind of like, you don't have a memory, you don't have a feeling. It's a really strange, like empty shell, like human, but not human at the same time. It's a really machine. So like,
I think, Juntai, there's also a double-edged sword here. If you try to build anything anywhere else in the world, nothing is standardized. You have to create your metal stud. You have to create have your wood studs cut up, right? In America, with this type of technology and with this type of commercial activity, it also made the activity of construction a lot easier. I mean, it's really a double-edged sword. But if you're trying to design something, build something anywhere else, there are so many things you need to research that you can't find. Where in America, you go into a Sweets catalog or go into some of these product materials, it's all there, you specify it, you draw it together, and it works. I mean, almost. But I mean, I think that's the thing that we architects need to think about, because there needs to be some way to make these materials known. So institutions like U.S. Green Building Council, BREEAM, and other places are important for us to give the background. But somehow also there needs to be almost a universal place where you could select materials and you could easily, quickly build something, instead of getting every wood stud cut out from a certain tree.
Mm.
I mean, I think that's what's so complicated, us being architects. I mean, industry products control this process, but at the same time, there is a way that they make the process easier for us to actually work, to finish, to build.
There was like, it is really interesting. There was like prefabrication researchers, like directly involved in cotton wool, glass metal cotton wool design. Same people moved on. They designed the cotton wool. So cotton wool technology you have came from same people. So they tried really hard to push that direction. But like irony is, like a lot of people, like speaking of Miss Vandeo, for example, like Miss is kind of like, really spiritual, artistic, like, oriented architect. But at the same time, who were trained by Miss Vandeo were translator. He didn't speak English, but when he came to Chicago, there was a translator who were trained by Miss Vandeo. One went to Princeton, the other one went to Columbia. They were students at Bowles, came back. They were like asked by Miss Vandeo to be translators at IIT. And they were partners at SOM. And then, Miss Vandeo also asked these guys to produce detailed drawings. So like sometimes the boundary between like this corporate world and then more like atelier-oriented design world is very blurry. I don't know, I think like the same people lived in two worlds at the same time.
I think what's also interesting is that in building construction, we use the textbook of Edward Allen. And I'm really appreciative that every time that a new edition comes up, some materials get added, some materials get removed. So there is also some in the educational community and in the construction community, there is also an effort to try to eliminate these materials and teach the use of other ones that can replace them. So I think our students probably benefit a lot from Edward Allen's book, but that's one quality. If you look at earlier editions of the book, each year they add and subtract materials and they go deeper and deeper into what is sustainable in the long term, what is the life cycle use of that material. So I think that's a good thing, a positive thing that for us to be optimistic about.
I have a different point of view going back to what Michael Shorting was mentioning. I think that there is a fundamental systemic issue of corporation, which is based on Fordism, right? Henry Ford managed to convince the Congress of the United States that there was going to be a byproduct of the advancement of technology, and that was going to cause casualties or byproducts of the growth of American industry, and that there were going to be death, casualties, because of the byproduct of this advancement. And he made, there's very interesting research that he made a comparison between American citizens' votes transformed into money advancement business. And he was able to convince the Congress that there was a certain amount of money, a threshold, in which the Congress should look at money representation in exchange for vote representation. And I think that that's where corporate America is based on that logic, in the logic of Fordism, that money making machine is equal to voting representation. And there's a very interesting analysis and criticism of that type of logic. To me, the problem that I have with Edward Allen's book that you mentioned, Behan, is that is representing the industry and is not representing architecture. And I think that I teach building constructions, right? And I think that in order to present a cultural resistance to Fordism, the standardization of right change, product industrialization, separation of labor, and so on. To me, from a cultural point of view, we have the role of the architect actually designing from a different cultural point of view than the industry. For instance, details or different ways of combining off-the-shelf construction methods. To me, the problem of the Edward Allen's book is that it's representing more the industry and Home Depot way of construction than an architecture way of building. And I would definitely think that that comes from a separation of labor and from an industrialization of a system of construction. To me, the issue here, at least from the point of view of the architecture and technology, is how much are we able to design our own parameters here at the School of Architecture and Design at the New York Institute of Technology, and how we're able to actually present a different alternative to the byproducts of the industry from an architecture point of view. Otherwise, we become simply executors of systems that are already in place, and there's no really agency, by the way. I think that the authorship of the architect is totally gone. That's why I think every year architects have less ranges of possibilities in terms of what's out there.
I think since you're directly referring to Edward Allen's book, I think in terms of construction methods, in terms of aesthetics and kinds of buildings that they introduce, you're absolutely right. But I think in terms of materials, it's one of the very few books that introduce ordinary day-to-day working materials and presents constantly research on their sustainability in life cycle effects. So I mean, I think it's again a double-edged sword. How do we teach students how to build and what to build with? You know, there has to be some place somewhere where they can find this information. I mean, I don't think the buildings need to look like that, but the materials are very important because ordinary day-to-day materials end up being the things that people use every day when they graduate from school.
At least from where I come from, construction is not architecture. Architecture is different from construction. And I think that the Edward Allen's book reinforces the idea that construction is architecture. And I think construction is not architecture. I think that you need theory, but there is questions in the chat. Maybe we should go to those.
Yeah. Let's see. So from Jose Luis, one of the slides you present the house of the future. Are we working toward the house of the future? I did some studies on multi-generational family where the parents, grown children, and grandchildren can all share a house.
Yeah, I answered. It's not like, really about their future. It was more like after the war. It's a preparing
see.
for the war.
I see. Right. So you indicate as much.
Yeah.
We have time for about one or two more questions.
Any
Maybe
student?
any students, any reactions, thoughts from the students? Did the presentation make sense? Did you get enough context?
I'm very happy. Like more than 70 people came out. I expected like 15, 10, really. I respect you. I really love your compassion today. You saved me.
I mean, not to be polemical, but I would venture that the idea of authorship probably died a long time ago in architecture. That's my answer to your statement before, Pablo. That, I mean, maybe with Duchamp, it ended with Duchamp and his ready-mades. Who knows?
No, I totally agree. But at the same time, the question is, what do we do, right?
Yeah,
like, what are we responsible for, and what are we really doing? What are we actually really doing that is relevant? That's what I mean. I don't mean authorship in that sense.
Right.
And I know that it comes across because it's a word that is charged.
Of course.
I need to find another word, but the same happens with the software, right? The software is already designed, and what do? You just apply a tool, right? And that becomes a design, right? The same happens with construction systems. When the IKEA, right? Like, do you become the IKEA disobedient? Is that enough, right? Is that enough to go to Home Depot and combine things in a different way, right? That's what I'm referring to.
Vanessa asked a very important question personally. What role, if any, did the Architecture Archive contribute to this research? Not just this research, many of my research actually. It's a changing archive research, to me, very, very important. I know archive is dying because whenever I go to like remote university library, they treat me really well. Sometimes, like, University of Idaho library a couple of years ago, they were like, I attended there, I went to the library, there were 5 people waiting for me. They said like there were so few people coming in, so they were so excited about me. So they took care of me really well. So I know that's a difficulty, but I still like libraries are crucial. But at the same time, these days our research is not like really conventional architecture. We don't rely on traditional archives anymore. We are more into technological archives, technological drawings, or sometimes business interactions, like law firms, catalogs. So I think like I don't think architecture archive is less important. I think it need to expand to incorporate like more materials, like climate related issues, all different things. So yes, it was very important. I hope like it's more important later.
This is a comment from Ivan Markov. I teach structures and like John Fernandez's book, Material Architecture. I don't want to get us too far afield into the debates about which textbooks we should be using in our classes. But I do want to say in closing, on November the 18th, we have a very exciting event lined up titled Urbanism, the Urbanism of the South Chinese Metropolis. And this is a collaboration between NYIT and Tsinghua University. And it's been organized by our distinguished faculty colleague, Tom Verabes. So I very much encourage all of you who are available to join us for that event, which will take place once again, November 18th at 7 p.m. Not at our regularly scheduled 6 p.m., but rather at 7 p.m. And with that, I also really want to offer my sincerest thanks to Professor Jung for his brilliant and very thought-provoking presentation. I'm really grateful for the discussion and also for the rigor of your analysis.
Thank you so much. Really, I really appreciate your attendance and then good conversation.
Yeah, and thank you. And thank you everyone out there for turning up and showing some love to one of our own. Okay, so everyone stay safe, healthy, and have a lovely evening.
Thank you.
Bye. Thank you.
Thank you. Thank you so much.
Thank you.
Thank you, Pablo.
Thank
Thank you,
you.
Tom. Thank you, Michael.